with a new concept of something called as consistency and inconsistency. So far, we have seen a few sums, the four methods of how to solve the linear equations in two variables. Now let's learn this different concept of consistency and inconsistency. Let's see what is the concept. Let's consider two equations. X plus y plus 3 is equal to 0 is equation number 1, and x minus y plus 1 is equal to 0 is equal to equation number 2. Now you solve these equations by any of the four methods that you have studied, and trust me, you will get the value of x as minus 2 and you will get the value of y as minus 1. Now this x is equal to minus 2 and y is equal to minus 1 is the only solution possible for the given equations when we solve the equations together. Now remember, this is a very important concept of linear equations in two variables. In linear equations in two variables, individually when we solve them, when we solve a linear equation in two variables separately or individually, it will have infinite solutions. Now when we see infinite solution means what? It means that a linear equation in two variables, we will get infinite values of y and infinite values of x which will satisfy the equation. But when we solve them together, we get one and only one solution that would satisfy both the equations. We call them unique solution. So here in these two equations, x is equal to minus 2 and y is equal to minus 1 is a unique solution. I mean, this is the only solution which will satisfy both these equations, equation 1 and equation 2, when solved simultaneously. That's why they are also known as simultaneous equations. Right? Now when you draw these on the graph paper, you will get two lines which are intersecting at a point, and that is a concept of graph that we have seen. The point of intersection is nothing but the solution. And here the point of intersection will be minus 2 comma minus 1 because that is the solution, as simple as that. So this is case 1, a case where two equations have got unique solution, and you plot these equations on the graph paper, you will get two lines intersecting at a single point. Clear? Let's move on. Let's take these equations. 2x minus y minus 1 is equal to 0 is equation number 1. 2x minus y minus 4 is equal to 0 is equation number 2. Now when you subtract the two equations that we used to do in elimination method, minus 1 on the other side, minus 4 to the other side, we get 2x minus y as one equation, 2x minus y is equal to 4 as the other equation. Subtract, change the signs. What happens? 2x minus 2x gets cancelled, minus y plus y also gets cancelled, and 1 minus 4 is say minus 3 or whatever. Don't you feel we are getting something very weird, something like 0 is equal to minus 3, both the variables are getting eliminated, you are getting minus 3 comma is equal to 0, 0 is equal to minus 3, which is not true. So what do we conclude? We conclude that these equations have absolutely no solutions because we couldn't solve it and we were getting something meaningless. 0 is equal to minus 3 or 3 is equal to 0 or whatever, which is not true, right? So this is an example of the equation which have absolutely no solutions at all. Moreover, when you plot it on the graph paper, you will get two lines which are parallel to each other. No intersection, no solution, as simple as that. So that's case 2 where equations have got no solution and the lines are parallel to each other. Let's look at the other two equations now. X minus y minus 2 is equal to 0 and 2x minus 2y minus 4 is equal to 0. Equation number 2. Now observe equation number 1 and equation number 2 very closely. What do you observe in 1 and 2? When you multiply equation number 1 by 2, we get the second equation. Multiply the first equation by 2. You get 2x minus 2y minus 4 is equal to 0, which is nothing but the second equation. You divide the second equation by 2, we get the first equation. So what does this mean? This indicates that just by multiplying or dividing the entire equation by 2, you get the other equation. It means that equation 1 and equation 2 may look different but actually are the same. Just that we have simplified it by multiplying by 2 or dividing by 2. So this is the same form or rather different forms of the same equation, right? And because 1 and 2 have the same equation, they will have the same set of solutions. And just now I said equations same or one equation, a linear equation in two variables, will have infinite number of solutions. This is an example of it. The equations are looking different, but they are exactly the same. So they will definitely have infinite number of solutions because they will have infinite values of x and infinite values of y which will satisfy the given equations. And because the equations are same and they have infinite solutions, they won't intersect on one point on the graph paper, they will intersect on every point. In other words, the lines will be overlapping or the lines will be coincident. So these are three different cases or three different types of simultaneous equations. Type 1, where equations have got unique solution and the lines are intersecting on the graph paper. Case 2, equations have no solution, lines are parallel on the graph paper. And case 3, where the equations have got infinite number of solutions because the equations are same, it's only one equation, and the lines are overlapping or coincident on the graph paper. Now in the exam, what type of a question do you get? Remember this, the equations with unique solution or infinite solutions, I mean the equations which have solutions are known as consistent equations. And the equations that do not have any solution are known as inconsistent equations. So this is basically the concept of consistency and inconsistency. The equations with solutions may be a unique solution or may be infinite number of solutions. Such equations are known as consistent. And the equation having no solution is actually known as inconsistent. Now here we could easily find out whether the equations are having solutions or no by solving it with one of the methods that you already know. But in the exam, the question will be without actually solving. You are not allowed to solve. You are not allowed to use your substitution or elimination or graphical or the cross multiplication method to solve, right? Without solving, find out whether the equations have got unique solution or no solution or infinite solution. Now the question is that possible? Yes, it is possible. How? Let's see. Let's understand the conditions now. Look at the first equation, the first case, and like we did in cross multiplication method, let's find the values of a1, b1, c1 and a2, b2, c2. From the first equation we can find the values of a1, b1, c1, a1 coefficient of x, b1 coefficient of y and c1 the constant term, something which we have done in the cross multiplication method, right? Let's find the values of a1, b1, c1 and a2, b2, c2. From first equation, compare it with the standard form, we get the values of a1, b1, c1. Let's do it. And from second equation, later we'll find the values of a2, b2 and c2. First equation, observe a1, the coefficient of x is 1, so a1 is equal to 1. Similarly, b1 is also equal to 1 and c1 is equal to 3, right? From the second equation, we get a1 is equal to 1, b1 is equal to minus 1 and c1 is equal to 1. So first thing what we need to do is get the equations in the standard form, then compare it with the standard form. From the first equation get a1, b1, c1. From second equation you get a2, b2, c2, right? After doing this, we need to find the ratio a1 upon a2, b1 upon b2 and c1 upon c2. Let's find a1 upon a2. What is a1 upon a2 here? a1 upon a2 is 1 upon 1, which is 1. b1 upon b2 is 1 upon minus 1, which is minus 1. What do you observe in a1 upon a2 and b1 upon b2? a1 upon a2 is definitely not equal to b1 upon b2. And when a1 upon a2 not equal to b1 upon b2, whatever is c1 upon c2, we don't consider. Whenever a1 upon a2 is not equal to b1 upon b2, we conclude that the equations have got unique solution. So the equations to be unique, the ratio of the coefficient of x should not be equal to the ratio of the coefficient of y. Whatever be the ratio of the constant doesn't matter. May be equal, may not be equal, doesn't matter. So the condition for unique solution is A1 upon A2 should not be equal to B1 upon B2. As simple as that. Now let's derive the condition for no solution. Let's find A1, B1, C1 from the first equation. What do we get? A1 is 2, B1 is minus 1, C1 is minus 1. From the second equation we get A2 is equal to 2, B2 is equal to minus 1, C2 is equal to minus 4. Now let's find the ratios. A1 upon A2 is 2 upon 2, which is 1. B1 upon B2 is minus 1 upon 1, which is also equal to 1. So you all can see A1 upon A2 is same as B1 upon B2. Whenever both are equal, it becomes important for us to find C1 upon C2, which is minus 1 upon minus 4, which is definitely not equal to 1. So what do we observe? A1 upon A2 is 1, B1 upon B2 is 1, but C1 upon C2 is not equal to 1. So the conclusion is A1 upon A2 is equal to B1 upon B2, but it's not equal to C1 upon C2. The equations have got no solution. That's the condition for no solution. Third, you must have guessed it right by now. Let's do it fast. Equation 1, you get A1 1, B1 minus 1, C1 minus 2. From second equation, A2 2, B2 minus 2, C2 minus 4. Now what do we do? Find the ratios. What is A1 upon A2? A1 upon A2 is equal to 1 upon 2. What is B1 upon B2 here? B1 upon B2 is equal to minus 1 upon minus 2, which is again equal to 1 upon 2. And C1 upon C2 is minus 2 upon minus 4, which is also equal to 1 upon 2. So what do you observe? It's very clear that A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. And whenever all the three ratios are equal, has to be equal because the equations are same, we say that the equations have got infinitely many solutions. So these are the three conditions that you should not forget, the conditions of consistency, inconsistency. Let's see a small table just for your understanding. The condition whenever A1 upon A2 is not equal to B1 upon B2, the lines are intersecting on the graph paper, the equations have got unique solution and the equations are consistent. Solution, consistent, simple as that. The second condition that we studied was A1 upon A2 is equal to B1 upon B2, but it's not equal to C1 upon C2. The lines are parallel, equations have got no solution and they are inconsistent, right? The third is all the three ratios are equal, the lines are overlapping or lines are coincident, right? Algebraic interpretation is they have got infinite number of solutions. Because there are solutions, the equations are definitely consistent. So that's the concept.